Hi, I'm Alex Satmarie. I'm a mechanical engineer at Hexagon, and I help students and professors put our simulation software to work. In this video, I'll be describing a set of instructor resources that we've developed that help people teach solid mechanics using finite element analysis. You can find out how to access these resources by checking the description below. In this video, I'll be really talking to instructors, and I'll be explaining why you might want to use finite element analysis to teach solid mechanics, and showing you the resources that we've put together and how they can help you do that. There are three main ways that people can get experience with solid mechanics concepts: qualitative demos, experiments, and simulations. With qualitative demos, you could do things like use putty to see the Poisson effect, or see what beam cross-sections look like in bending by bending a pool noodle. Qualitative demos are exciting, and they give tactile experiences with solid mechanics. Experiments are valuable because students can learn how to use real engineering equipment like tension testers. Experiments also give rigorous quantitative information. Simulations are valuable for two big reasons. One is that it's very easy to vary parameters and see their effects. So you could change what's the applied load, or what is the cross-section of a beam, and what is the resulting stress and deflection in the beam. Simulations are also great because, unlike qualitative demos or experiments, you are seeing what is the response of the part as a continuum, as opposed to what is its bulk response. So with a simulation, you can see what is the stress profile of, say, a part in torsion versus in bending, and you can see what are the actual stresses at every point within that part. Each of these approaches also has limitations. So qualitative demos are qualitative. They don't give you quantitative information, and they make it hard to draw inferences about cause and effect. The limitations for experiments include the cost and time involved, and helping students learn how the experiment works. If they don't really understand the equipment, it's hard for them to make sense of the experience. For example, if you don't really understand what a strain gauge is doing, it doesn't really help you learn that much about strain itself. The main limitation of simulations is that students need to learn how to use professional-grade software. This difficulty can be mitigated by giving students templates and tools that make it easy to carry out the simulations. I'm going to tell you how I've set that up for MSc Apex in particular. Here, I'm showing what your students can see if they do finite element analysis in solid mechanics. These experiences are powered by custom tools that are built into MSc Apex, and also by templates and instructor resources that I'm going to describe to you next. For each of the lessons corresponding to this content, there are step-by-step tutorials, as well as handouts that can introduce students to the content. And for beams and column buckling, there are even challenging exercises that would be appropriate for inclusion on homework. Let me talk you through what I've got for beams in particular, and that'll give you a general idea of what's available. For each topic in the instructor resources, there are step-by-step tutorials that get brand new users of finite element analysis software up to speed and having meaningful experiences with solid mechanics concepts. Some of these experiences are powered by custom tools that are built into MSc Apex. In the example shown here, that makes it so that it only takes 4 easy steps to build a model of a beam that is ready to be run by the solver. It's also very easy to just change numbers in the form and update the model so that it can run again, and you can see things like how does changing force change the resulting deflection of the beam. People learn best not just by having experiences, but by having a chance to reflect on those experiences. It's also valuable to get those experiences in before students are given a real explanation as to what's going on with the phenomenon. So the intention is for some of these exercises to be done before class or in class, but right before a concept is being lectured on. To structure the exploration process, students would fill in tables. The tables guide them on good parameters to vary that would lead to interesting results. So for example, they're told how to vary the cross-section of a beam or what the material in the beam is, and then they would see the resulting stress and deflection. So that students go from those observations to seeing cause and effect, they have questions to fill out, and these would help start discussions among students on how does solid mechanics work. For beams and columns, there are also challenge activities that help students do design on authentic structures in industry. The example here is fictionalized, but it's based on a real machine from a real factory that I've helped students do some design work with. Students would compare a couple of different options, do loading analysis, and select the cross-section for the beam. Before I joined Hexagon, I was a mechanical engineering professor, and I used simulation to help students learn engineering concepts. If I were teaching solid mechanics, this is pretty much the approach that I would use. You can find out how to access the instructor resources by checking the description. I want you to try this in the classroom and let me know how it goes. Also, let me know if you have ideas for how to expand or refine this curriculum. Finally, if you're interested in teaching engineering using simulation, I want you to get in touch. It is my full-time job to develop resources that help you put software to work in the classroom. And I do that not just for finite element analysis, but for a range of simulation software that Hexagon offers. Thanks. Have a great day. Bye.